Okay, I just want to go ahead and take a moment to go through the video showing you the Inq-Its lab that you'll be going through. Now, first one, you want to preview it. It's going to talk about forces in motion on Earth. We're going to talk about different sleds going down ramps at various heights, different materials. Now, you could do various things. You could see how the mass, the ramp height, but we're going to look at the material, impacts the velocity of the sled, the time it takes to reach the bottom, and the force with which the sled hits the spring. So, to see how forces can change, you'll be able to manipulate the mass of the sled, the height of the tower, or the roughness of the ramp. For today's purposes, we'll be just adjusting the roughness of the ramp. When you've done, click yes, I read the directions, and you can submit. Then you go to the next part, and it'll show you the pre-part. Pardon me, the pre-analysis. So you go through, answer the questions. This is more of a completion grade. I guess it's a video key, so I can go through it. Morris and Kate both drive trucks. Morris drives a 1-ton truck, and Katie drives a 2-ton truck. Both vehicles have motors and tires are the same size. Morris and Katie are at a stoplight, and both step on the gas at the same time. Morris pulls away faster. Why does Morris's vehicle take off faster? Because Morris's tires cause greater friction, because Katie used a different type of gas, because Morris's truck has more gas, because Katie's truck is heavier. Well, because Katie's truck has more mass, it takes more force to accelerate it. The graph below represents the motion of a runner during a 2,000-meter race. That's just a distance time graph that we've seen. During which time is the speed constant? Well, between 0 and 2.5 minutes, it's constant. From 2.5 to 6, it's constant. And from 6 to 8, it's constant. It's not constant the whole way through. It's not constant 2 to 8. 4 to 8, it's not. It's already changing. So the only time that it's constant of those choices is between 6 and 8. A ball will be rolled down 4 times, in which the following situation will some of the kinetic energy of the ball be converted into potential energy as the ball rolls. As the ball rolls up, ball rolls down. Large ball rolls 2 meters, small ball rolls 4 meters. As the object rolls up, it will be storing in potential energy because eventually it will roll back down. The arrows on the diagram below represent the forces acting on a moving bicycle at 2 different times, time 1 and 2. The length of each arrow represents the amount of force being applied. So we have time 1, where we have forward and backward arrows are balanced, top and bottom arrows are balanced. Now we see that there's a larger forward arrow pushing this way than there is pushing this way. So this would be an object that's starting to move in a forward direction, move slower in a forward direction. Faster, it would be speeding up because the backwards force is faster, so it'd be moving faster in a forward direction. Student rolls the ball down the ramp, shown in the picture below. The ramp is supported by 4 stacked books. Student removes 2 books from the stack, supporting the ramp, and rolls the ball down the ramp again, which the following best describes how the ball's motion is different. Because you take 2 books out, it should be a lower ramp. The ball will not accelerate as fast. It will not have a higher speed. It will accelerate less quickly because it's not as steep. It will not have a higher average speed because it will not be going faster. It will take more time to reach the bottom, and it will not have a higher speed at the top of the ramp. What must be true for a car to move forward at a constant speed? The forward force of the car is moving forward at a constant speed. The forward force has to be balanced with the force of friction. All right, finish and submit. Now you're going to go into this third part, and this is the actual lab itself. And yes, he will pop up, just that's fine. The question is, determine how the roughness of the ramp impacts the time to end the ramp. So we're going to see how, if we make this ramp, we're going to increase the friction of the ramp. We're going to see how that impacts the object. So think of it this way. If it was an icy ramp composed to a rough ramp, how would that change the time to the end? So determine how the roughness of the ramp impacts the time to the end of the ramp. If I increase the roughness of the ramp, we could go decrease too if you want to. Yeah, we could do decrease too. Either one is fine. So if I decrease the roughness of the ramp, then the time to the end of the ramp should increase. The less friction there is, the faster it should go. And again, you can try it the other way too. It doesn't matter as long as you follow through. Now you say I'm ready to run the experiment. Now they give you choices. You can change the height of the tower. You can change the mass of the car. You can change the roughness of the ramp, whether it's very smooth or has increases like sandpaper. You can also increase the gravity based on which planet you're on. We just want to be on, we're going to go ahead and reset this. We're going to do this on Earth, the lightest car, and we'll just do the basic ramp. So if I was to refresh this, yeah, all right, let's hope this, let's make sure, I'm going to refresh this page, just to make sure it's on the right page. So again, I apologize for this, but if I decrease the roughness of the ramp, then the time to the end of the ramp should decrease because it should go faster. Okay, they start you off on the moon. Let's do Earth. Let's do Earth. Now, we're not going to change the height of the tower. We are not going to change the mass of the sled. We are going to change the roughness of the ramp. We'll start off with a default, but we should be on Earth just to make sure it's kind of easiest for us to understand. We're going to go ahead and run the trial. And we see that it takes our data, add to our results. Now again, we are changing the roughness of the ramp. So let's go ahead and make the ramp a little bit rougher. The 0.15 means it's more rough. Run the trial. Okay, it collects our data. Switch to the 0.2. Okay, add the results. And finally the 0.25, run your results. Now it's all you have to do for the lab itself. Okay. You do not have to change all these settings. All we're changing is the roughness of the ramp. We have enough data to support what we want to find. So I'm finished collecting data. So what we can look at. So here's what I did. I decreased the roughness of the ramp. And again, if you increased it, that's fine. Just make sure that you keep it the same on both the post and the pre and the post. So when I decreased the roughness of the ramp, the time to the end of the ramp was, so here's my ramp roughness. The bigger the number, the bigger the number, the more rough it was. Here I have my column that shows the time to the end of the ramp. And I'll notice with the roughest setting, it was 2.44 seconds. The third roughest setting was 2. So as my roughness decreased, my time decreased as well. That supports my hypothesis. And I want to choose all 4 of those data points to evidence my claim. Then when you're done with that, I'm done with my analysis, and that should bring you to your last page. So I want you to show the data. Okay, it says, write a sentence that states what you found out about the scientific question you investigated, provide enough details so a friend who did not do the experiment could learn from your description. So what we did was we looked at how the roughness of the ramp decreased the time to the end of the ramp. So I could just say something simply, the lower the friction of the ramp, the shorter the time for the car to finish the ramp. And we can see that when the roughness was the longest, it took the longest amount of time. When it was short, when it was very smooth, it took very little time. Provide and describe scientific evidence from your data table that supports your written claim. Trials support data, rougher ramps, increased time. Okay, so we saw the rougher the ramp, the greater the amount of the smaller it was to finish. So explain why your evidence, what you wrote in box 2, supports your claim. Okay, so I said, well, the trial supports the data, the rougher ramps increase time. And I can just say that as combined. In the trial, the ramps with the roughest, well, let's go with their hypothesis. Smoothest surface showed the fastest time to finish the ramp. All right, you have a lot of characters, but that's all I'm really looking for. Again, the lower the friction on the ramp, the shorter the time for the car to finish. What's scientific data? Well, my results show that. The rougher the ramp was, the slower the time was. Okay? And then again, just my reasoning, well, in the trial, the ramps with the smoothest surface showed the fastest time to finish. That supports my hypothesis. I finish and I submit. All right, so that is a video key of how to complete that. Hopefully that helps. Otherwise, you can see me in study hall and I can walk you through it.